Yes, sir.
So, good morning, everyone. And I think Samra, the other student, she is still not able to join.
Yes, sir.
Okay. So, in my last class, I have shared with you the presentation on chromatography. I hope you might have
Yes, sir.
gone through it.
Yes, sir.
Okay. So, how much of it you are able to get?
So there are some topics which I was not able to get.
Mm-hmm. So, let us start discussing it. Okay, so is the screen is visible to you?
Yes, sir.
Okay, then. So we discussed about basics of chromatography, about different classifications, and I hope you are very clear with that. So let me ask some questions before we start. So what is difference between reverse phase and normal phase chromatography?
Sir, in a reverse phase chromatography, we take the stationary phase as a non-polar one.
Okay, and what is the mobile phase?
So the mobile phase, it might be polar or non-polar.
No, no, no. We start with polar because
Okay, sir. Okay, sir. Yeah.
we have to take opposite mobile phase. Like if our
Yes, sir. Yes,
stationary
sir.
phase is non-polar, then we have to start with a polar solvent.
Yes,
And
sir.
what is
Yes,
the
sir.
most common solvent that is used on reverse phase chromatography? What is the most common solvent that is
Hello.
yes? What is the most common solvent that is used as a mobile phase on reverse phase chromatography?
So the silica.
No, silica is a stationary phase in
The
normal
stationary
phase.
phase. Yeah.
I am asking about mobile
Okay.
phase.
Mobile phase.
Mobile phase in
So,
reverse phase chromatography.
sir, we take that the C18 columns and.
But again, I'm saying C18 column is a stationary phase. Okay.
Okay, sir.
The mobile phase we start with water. The maximum ingredient is water.
Yes, sir. Yes, sir.
And in water we mix organic solvent, right? Because
Okay,
water
sir.
is
Yes, sir.
highly polar. We discussed in our previous class that since water is
Yes,
having
sir.
only two bonds and both the bonds are polar, so it is one of the most polar solvent available with us. Okay. Now, if you
Yes,
mix
sir.
any organic solvent with water, like suppose you generally we mix either acetonitrile or we mix methanol. Now, if you
Methanol.
mix
Yes, sir.
methanol, which one is more polar? Water is more polar or methanol is more polar?
So the water is more polar.
Okay, very good. Why?
So because you have told before that they have the two bonds that are polar, and in
Yes.
methanol there are less polar bonds.
Yes, because in methanol we have only one OH. So there we have the polarity. Rest three bonds, that is
Yes, sir.
CH bonds. Because what is the
Yes, sir.
molecular formula of methanol? Yes, what is the molecular formula of methanol?
So methanol.
So what
Sir,
you are doing? You are
CH3OH.
it seems you are not stable. You are doing something or you are
No, sir.
traveling.
No, sir. I'm not traveling. I'm not doing there, sir. A network issue. I'll get your voice after a little time.
Okay, okay. So what is the molecular formula of methanol?
So CH3OH.
CH3OH. So we got three CH bond, CH, and one
Yes, sir.
carbon hydroxyl bond. So that carbon hydroxyl bond is a polar
Yes, sir.
bond, and the CH3
Yes, sir.
CH bonds are non-polar bonds. Okay, that's why methanol is
Yes,
polar,
sir.
but it is not as polar as
As polar as water. Okay,
water.
sir.
Okay, so when
Okay,
we
sir.
mix methanol with water, then it is miscible because of the interaction of the OH bond with the OH of water. Okay, but
Yes, sir.
yes, we
Okay, sir.
have some non-polar interactions, and these non-polar interactions, like the CH3 bonds, they interact with the C18 column. That is the methyl chain of the in the C18 column. Okay, so more the percentage of methanol in water, higher will be its say non-polarity. It will be lesser polar. So higher the percentage of water, the mobile phase will more polar. Lesser the percentage of water, the mobile phase will become non-polar. Okay. So in reverse phase chromatography, we generally start with higher percentage of water and gradually increase the concentration of organic solvent in that. Like if you know that there are two kind of HPLCs that we perform. One is gradient HPLC and another is isocritic HPLC. Have you heard about these words?
Yes, sir.
So in gradient HPLC, what we do that we like the strength of the mobile phase, it changes throughout the run. In isocritic HPLC, the strength of the mobile phase doesn't change throughout the run. Okay, so it's this a kind of illusion. I think there are three words
Sir,
you
can you
write.
please repeat? Hello, sir. Can you please repeat?
There are three words you write. You have pen paper handy with you. Hello.
Hello.
You have pen paper available with you.
Hello. Hello. Yes, sir.
So you write three
Yes,
words.
sir.
You write three words. One is elute,
Yes, sir.
ELUTE, elute.
Okay, sir.
Another is eluent, ELUENT, eluent. And third one is illusion, ELUTION, illusion. Okay.
Okay.
So when we say elute, can you tell me what is the word? What does the word elute mean? What is elute?
Sir, elute means just removing something.
So what is elute? So
Sir,
can
in
you
respect
just
of chromatography.
yes, in respect of
Yeah.
chromatography.
Yeah.
What is
So
elute?
in respect of chromatography, the components that are coming out from the chromatography.
Yes, very good. The component which are coming out of the chromatographic system are called
After
elute.
separation, yes, sir.
Yes, like if you see on my screen, so you can see how many elutes are there in this system. If you see on the screen, how many elutes are there on the in the system?
Sir, it's not visible on the screen. I can see only the.
Okay, the screen is not shared.
Sir, the screen was shared, but
Now can you see it again? I just refreshed it.
yes, sir.
Okay, now how many solutes are there in this system? How many elutes are there in this system?
So three are there.
Three.
Blue,
So
green,
elute,
and red.
so means solute means the component of the mixture
That are coming out. Yes,
that
sir.
are coming out. These are called elutes.
Yes, sir.
Now another word is eluent. What do you mean by eluent? Can you just draw some similarity? Some similarity from something, eluent,
Sir, eluent
solvent,
is.
eluent, solvent.
Sir, eluent might be that might be the mobile phase that helps in coming. That helps the elute substance to just come out.
No. I'm saying I'm giving you a hint. I'm giving you a hint. Eluent, solvent. I'm giving you a hint.
Sir, the mobile phase.
Yes, very good. So it's mobile phase. So eluent means the mobile phase under influence of which the elutes are coming out. Because the mobile phase is moving, the eluent is moving. The eluent
Yes,
is
sir.
pushing down the elute out of the chromatographic system, whether it is a column or whether it is a TLC system. Okay. Now the third one is elution. Elution means you can write down. So I think you have written elute means the solutes.
Yes, sir.
Eluent means the solvent, the mobile phase.
Solvent. Yes, sir.
Mobile phase, and elution is the process. Is the
Okay, sir.
process in which under the influence of eluent, elutes comes out of the column. So this is called eluted. Eluted means that solute which is coming out of the column is called eluted, right?
Yes, sir.
So we have three elute, elute 1, elute 2, and elute 3. Of all three are coming out of the column. This process is called elution. This process is called elution.
Elution.
Okay, now comes to the major point, that suppose if I am having reverse phase column, where stationary phase is?
Stationary phase is silica.
No, in reverse phase column, the stationary phase is C18.
Hello.
In reverse phase column, the stationary phase is derivatized silica. We call it like ODS column.
Okay, sir.
Means C18 word you use, na? C18 means it is
Yes, sir.
like it's a non-polar column. It is a
Yes, sir.
non-polar column. And silica
Non-polar.
is, what is nature of silica? Polar or non-polar?
So silica is polar.
Yes. So that's why you were saying
Yes,
wrong,
we
na?
add something. Yes, sir. Yes, sir.
Yeah, so how come you can say that silica is stationary phase on reverse phase column?
Yes,
Because
sir.
if the stationary phase is polar, then what kind of chromatography it is?
So this is the normal one.
Normal phase. Okay, very good.
Yes, sir.
So we were discussing about reverse phase chromatography. So in reverse
Yes,
phase
sir.
chromatography, the stationary phase is non-polar, and that is generally like we use C18 columns. Okay. Right?
Hello.
Yes, I am there. Yes, Samara. Yes, Samara, can you hear me? Yes, Samara.
Hello. Yes, sir.
Okay. So now I think I am audible.
Hello.
Yes.
Yes, sir. Actually, I had a call from the university, that's why it was muted.
Okay. So when we are using reverse phase column, then the mobile phase is water. We start with water. Now, if I use water as a mobile phase, will it be a strong mobile phase or a weak mobile phase? That is a question. Based on that, we will use a word called elution strength. Use a word called elution
Okay,
strength.
sir.
Okay. Now,
Okay.
in case of reverse phase chromatography, the column is non-polar. The column is
Non-polar.
non-polar. So if I use a polar stationary phase, whether the if I use a polar mobile phase, whether the mobile phase will interact strongly or weakly with the stationary phase.
Sir, it will interact weakly.
It will interact weakly. So if it will interact weakly, then the solute or the elute will interact strongly or weakly?
Sir, weakly.
No. I said solute. If the eluent, if the mobile phase is interacting weakly, then the solute may interact strongly.
Sir, can you
Because
please explain how come?
yes. Try, because your connection is poor. Na, every time we are disconnecting.
Yes, sir.
So you should have a good connection before the classes, na. But I do not know like what
Yes,
is the
sir.
problem at your end, because you are in Kanpur, na.
Yes, sir.
But Kanpur is a city which is having very good connection. I do not know why at your end the connection is not good.
Sir, I think there's a problem in my lab because I'm in
So
my
you
lab, not
just
at my home.
no, but then you always try to find out a good place in the college, na? Why
Yes,
you are
sir.
sitting in the lab? In that case, go and sit under a tree.
Okay, sir.
Go in the
I'll
park,
try.
sit under a tree, and then have a good interaction. Otherwise, see, na, I'm spending 1 hour for you, na, 1.5 hour for you,
Yes, sir. Yes, sir.
and you are the only student. So that is also a difficulty, na, for me, because I did it because Dr. Anand requested me, and I
Yes,
wish
sir.
that students should understand the concept what I am telling, right?
Yes, sir. Yes,
Because
sir.
after all, see, na, like I also have a lot of work. Anyhow, but you try to find a good connection, na? Because every time
Oh,
I'm
okay, sir.
repeating the same thing, na? It's not good.
Okay, sir.
So wherever, like, you just check your connection in classroom, in corridor, go to somebody else has joined who is IGMC.
Yes, sir. I think he's the one who will record the video.
Okay, okay. I'm already recording the video and
Yes, sir.
I'm sharing it. Let me just talk to
Okay,
the
sir.
person.
Okay, sir.
Hello.
Hello, yes, sir. It's audible.
Okay, so who is IGMC? Please introduce yourself. Hello.
सर आईजीएमसी सर मैं रिकॉर्डिंग कर रहा हूँ सर.
Okay, okay. So actually, I am sharing every day. I am sharing it on some email given by Dr. Anand. So do I need to send it because I am recording and then I'm sending, and it takes time because it is almost 50-60 MB file every day.
यस सर.
So do I need to send it today onwards or there is no need?
सर अगर भेज देंगे तो सर बढ़िया रहेगा, तुरंत हम कर लेंगे.
हाँ नहीं, मैं तो भेजता हूँ, मैं उसको भेजता हूँ, बट वो क्योंकि कम से कम 50-60 MB की फाइल हो जाती है ना, तो
जी
50-60
सर.
MB की फाइल भेजने में ही जो है वो समय लगता है, पहले कन्वर्ट करता हूँ मैं उसको, फिर भेज पाता हूँ.
हाँ सर वो तो है ही सर.
चलिए, एनी हाउ, ओके, थैंक यू.
ठीक.
So Samara, you try to find some good connection, okay?
Okay, sir. Okay, sir.
Okay, so what I was telling you that suppose in case of reverse phase chromatography, the stationary phase is non-polar, and if I am using water as a solvent which is polar in nature, so interaction of the mobile phase with the stationary phase will be low. So when
Low.
the
Yes, sir.
interaction of the station mobile phase with the stationary phase is low, then solute can interact freely with the stationary phase, right?
Okay, sir.
Solute can
Okay, sir.
interact freely with the stationary phase.
Freely with
So
the. Okay, sir.
the interaction of the solute with the stationary phase will be more. So when the
Okay, sir.
interaction of the solute with the stationary phase will be more, they tend to absorb. And if they tend to
Okay, sir.
absorb, then their movement will be fast or slow.
Their movement will be slow.
They're very good. Their movement will be slow. That means a
Yes,
compound
sir.
which is adsorbed on the stationary phase, its movement will be slow. Okay. Now,
Okay,
if
sir.
I add some organic solvent in water, then its polarity will increase or decrease.
Sir, then its polarity will decrease.
Very good. When its polarity will decrease, its interaction with the C18 column will increase or decrease.
Sir, increase.
Its interaction will increase. Very good. Now, when the interaction of the
Yes, sir.
mobile phase with the stationary phase will increase, what will happen to the interaction of the solute with the stationary phase? Will it like there will be some change or there will not be any change?
Sir, there might be some change
Okay, very
because
good.
now
What
the
will that?
mobile
What?
phase is interacting.
So what will be that change?
Sir, it will not get absorbed that quickly or that efficiently.
Yeah, very good. So that means, suppose if you think about this column where three compounds, they were interacting with the stationary phase, right? And from this, we can make out that the blue one is having the strongest interaction and the red one is having the weakest
Weakest in
interaction.
one. Yes, sir.
Okay. Now, if I
Okay, sir.
use a mobile phase which allows the solute to freely interact with the stationary phase, then maybe the one like the red one will come out, but the blue and green will never come out. Why it will never come
Yes,
out?
sir.
Because their interaction is more as compared to the interaction of the mobile phase with the stationary phase, right?
Yes, sir. Yes,
So
sir.
to elute these compound, what we have to do? We have to increase some organic solvent to water. So when we will increase some organic solvent to water, maybe suppose I am saving it is 5% methanol in water, right? So
Yes,
5%
sir.
methanol in water, that means the mobile phase will now interact more with the stationary phase, right?
Okay, sir. Yes,
So
sir.
when it will interact more with the stationary phase, maybe that 5% methanol water can take out two compounds, red and green. But the
Green,
third
yes,
one
sir.
is still having very high adsorption on the stationary phase, and the mobile phase is not able to elute it out. So what we will do now?
Now we'll add more methanol.
More methanol, very good. Say suppose I now add 20% methanol to water, and that
The mobile phase, yes, sir.
20% methanol water is able to elute the third compound also.
Blue,
Now
yes,
you
sir.
just think about a situation. Instead of starting with first pure water, then 5% methanol in water, and then 20% methanol in water, if I start with 20% methanol in water, then what will happen?
Sir, the mobile phase interacts much efficiently with the solid phase. So,
then what will happen?
So the eluent did not get absorbed that efficiently.
Then what will happen?
And then they tends to elute out at a similar rate, I think.
Very good.
On
Very
the
good. Now
components.
see, very good. Now what you see, if I was using water, only red was coming out. If I was using 5% methanol in water, green was coming out. And if I was using 20% methanol in water, blue was coming out. Now, if I start with the column, so I started with the column with pure water. After some time, I added 5% methanol
Yes,
to
sir.
it. And after some time, I added 20% methanol to it, right?
Okay, sir.
But if I
Yes, sir.
start with the column, the process with 20% methanol in water, then all three compound will come out simultaneously. Means there will not be any separation. Okay. So this concept is called
Okay, sir.
strength of the mobile phase or elution strength. Elution strength. You are like write it, elution strength.
Okay, sir.
Elution strength. That is called the capacity of the mobile phase to elute.
Yes, sir.
To elute the components of a mixture. To elute the component of a mixture. Okay.
Yes, sir.
Now, for reverse phase chromatography, water is having high elution strength or low elution strength?
For reverse chromatography, water. Water is having. So water is having high elution strength.
नहीं अभी तो डिस्कस किया हमने सारा का सारा. अभी तो हमने बताया ना कि वाटर पोलर है. रिवर्स फेज क्रोमेटोग्राफी
Yes,
में
sir.
C18 कॉलम है जो नॉन पोलर है. तो वाटर का
जी, sir.
सेकेंडरी फेज के साथ इंटरेक्शन ही नहीं है. अब इंटरेक्शन नहीं है तो कंपोनेंट बड़े फ्रीली इंटरेक्ट कर रहे हैं. तो दैट मींस वाटर जो है वो लो इल्यूशन स्ट्रेंथ है. इट
Okay,
इज
sir. Okay, sir.
लो
Now I get it.
इल्यूशन
Thank you, sir.
स्ट्रेंथ.
Okay.
ओके,
Yes, sir.
नो इल्यूशन स्ट्रेंथ.
Okay, sir.
और अगर हमको वाटर की मोबाइल फेज की अगर इल्यूशन स्ट्रेंथ बढ़ानी है तो हमने क्या किया?
Yes,
उसमें
sir.
धीरे धीरे
Yes, sir.
उसमें ऑर्गेनिक ऐड कर दिया. हमने जैसे हमने
Solvent.
अगर हमने 5% मेथनॉल अगर
Yes, sir.
बना दिया, 5% मेथनॉल ऐड कर दिया तो स्ट्रेंथ और बढ़ गई. और 20% ऐड कर
Yes,
दिया
sir.
तो स्ट्रेंथ और बढ़ गई. और 50% ऐड कर देंगे तो स्ट्रेंथ और बढ़ जाएगी.
Yes, sir.
दैट मीन्स जैसे जैसे हम ऑर्गेनिक वो मतलब ऐड करते जाएंगे स्ट्रेंथ बढ़ती जाएगी.
Yes, sir.
और
Yes, sir.
हम ग्रेडियंट इल्यूशन में यही करते हैं. अगर मैंने अभी आपको बताया ना कि अगर मैं 20% से सीधा शुरू करूंगा तो सेपरेशन ही नहीं होगा, क्योंकि तीनों कंपोनेंट जो है वो इकट्ठे ही इल्यूट हो
Yes,
जाएंगे.
sir.
मेरा प्रोसीजर बेकार हो जाएगा.
Yes, sir. Yes, sir.
तो हम
Yes, sir.
क्या करते हैं रिवर्स फेज, मतलब हम ग्रेडियंट इल्यूशन में क्या करते हैं कि पहले मोबाइल फेज की स्ट्रेंथ कमजोर रखते हैं, वीक स्ट्रेंथ से शुरू करते हैं और धीरे धीरे क्या करते हैं उसकी स्ट्रेंथ को बढ़ाते चले जाते हैं. ठीक है. तो रिवर्स फेज क्रोमेटोग्राफी के लिए स्टेशनरी फेज इज नॉन पोलर और मोबाइल फेज क्या होती है?
हेलो सर, यस सर, कैन यू प्लीज रिपीट?
हाँ, तो रिवर्स फेज क्रोमेटोग्राफी के लिए स्टेशनरी
sir.
फेज इज नॉन पोलर
यस
और
सर,
मोबाइल फेज क्या होती है? वो होती है पोलर से नॉन
ग्रेडियंट
पोलर की
पोलर
तरफ
नॉन
जाते हैं।
पोलर, ओके सर, यस सर,
पोलर से हम नॉन पोलर की तरफ
नॉन
जाते हैं,
पोलर,
मतलब हम
यस सर,
स्टार्ट करेंगे पोलर मोबाइल फेज से और धीरे
यस
धीरे
सर,
उसकी पोलैरिटी को क्या करते चले जाएंगे?
कम करते जाएंगे।
कम करते चले जाएंगे। वेरी गुड। अब नॉर्मल फेज क्रोमेटोग्राफी में स्टेशनरी फेज की पोलैरिटी क्या होती है?
स्टेशनरी फेज इट्स पोलर।
पोलर होती है। जैसे आप बार बार सिलिका की जो बात कर रहे थे, तो सिलिका
यस
इज
सर,
ए वेरी कॉमन स्टेशनरी फेज यूज्ड इन normal phase chromatography. Okay,
यस सर,
so when we start with normal phase
यस सर,
chromatography, तो क्या होता है? वो अब हम मोबाइल, अगर हमारी स्टेशनरी फेज पोलर है तो अब मोबाइल फेज क्या होनी चाहिए?
सर देन इट शुड बी नॉन पोलर।
नॉन पोलर। वेरी गुड। तो नॉन पोलर सॉल्वेंट हम लोग ऑर्गेनिक सॉल्वेंट यूज करते हैं। तो वी स्टार्ट विद
ओके
से,
सर,
मतलब क्योंकि क्या है, अगर मैंने आपको उस दिन पिछली क्लास में एक्सप्लेन भी किया था कि रिवर्स फेज क्रोमेटोग्राफी आई बायोमोलिक्यूल्स के लिए,
यस सर,
क्योंकि अगर मुझे प्रोटीन का सेपरेशन करना है तो मेरी मोबाइल
यस
फेज
सर,
में क्या होना चाहिए? वाटर होना चाहिए।
यस सर,
क्यों होना चाहिए वाटर? बिकॉज प्रोटीन इज स्टेबल इन वाटर।
यस सर, यस सर,
ओके। अगर मेरी
यस सर,
स्टेशनरी फेज सिलिका है और अगर मैं वाटर एज ए
यस
मोबाइल
सर,
फेज यूज करूंगा तो क्या होगा?
स्टेशनरी फेज इस तरह का।
हम्म,
सर यू आर आस्किंग कि अगर हमारी स्टेशनरी फेज सिलिका है देन?
अगर मैं वाटर एज ए मोबाइल फेज यूज करूंगा तो क्या होगा?
स्टेशनरी, हेलो सर,
यस यस, आई एम देयर।
यस सर, यस सर, सर अगर हम स्टेशनरी फेज सिलिका है और वाटर यूज
जैसे
करेंगे
मुझे
तो
एक
दोनों
थोड़ा सा है
पोलर है।
थोड़ा सा मेरे को ये समझ में नहीं आता। जैसे अभी आपका कनेक्शन बहुत बढ़िया है
यस सर,
और अभी 1 मिनट पहले, 1.5 मिनट पहले आपका कनेक्शन बिल्कुल बेकार हो गया था।
यस सर, आपकी आवाज वाइब्रेट करने लगती है तो मुझे कैच करने में थोड़ा टाइम लगता है।
अब जैसे नाउ योर साउंडिंग वेरी
हाँ
गुड।
यस सर, नाउ इट्स ओके, यस सर,
चलो बताओ अब मेरे को।
हाँ ओके सर, सो
अगर हमारी स्टेशनरी फेज सिलिका है तो मैं वाटर यूज, अगर मोबाइल फेज यूज करूंगा तो क्या होगा?
सर क्योंकि सिलिका भी पोलर है एंड वाटर भी पोलर है तो उनका इंटरेक्शन हो जाएगा, तो
हम्म
जो इल्यूशन होगा वो इफेक्टिवली नहीं होगा।
तो वाटर जो है वो सिलिका के लिए एक स्ट्रॉन्ग मोबाइल फेज है या वीक मोबाइल फेज है?
सिलिका के लिए वाटर, सर इन रेस्पेक्ट ऑफ इल्यूशन,
हम्म
सर वीक होगा।
वीक कैसे हो सकता है? सेम पोलैरिटी होगी तो स्ट्रॉन्ग होगा ना,
ओके
क्योंकि
सर, द
सिलिका
इंटरेक्शन,
भी
ओके
पोलर
सर,
है।
आई थॉट कि आप ये पूछ रहे हो कि फिर इल्यूशन कैसा होगा, वीक होगा कि स्ट्रांग होगा।
हम्म तो वाटर जो है वो सिलिका के लिए एक स्ट्रॉन्ग मोबाइल फेज है और अगर स्ट्रॉन्ग मोबाइल फेज है तो सेपरेशन अच्छा नहीं होगा। क्यों अच्छा नहीं
यस
होगा?
सर,
क्योंकि वाटर के मॉलिक्यूल खुद जाके सिलिका के साथ इंटरेक्ट करेंगे
यस सर,
और
यस सर,
सैंपल के मॉलिक्यूल को इंटरेक्ट ही नहीं करने देंगे।
यस
और
सर,
अगर सैंपल के मॉलिक्यूल इंटरेक्ट नहीं करेंगे तो उनका एड्जॉर्प्शन नहीं होगा, और एड्जॉर्प्शन नहीं होगा तो वो मिक्सचर के रूप में ही बाहर आ जाएंगे। ठीक है।
यस सर,
तो
यस
अगर
सर,
अगर सिलिका मेरी स्टेशनरी फेज है तो मेरी मोबाइल फेज क्या होनी चाहिए?
सर नॉन पोलर ऑर्गेनिक सॉल्वेंट्स।
हाँ, वेरी गुड। नॉन पोलर ऑर्गेनिक सॉल्वेंट से हम शुरू करेंगे। कोई एग्जांपल दे सकते हो नॉन पोलर ऑर्गेनिक सॉल्वेंट का?
सर बेंजीन।
हाँ ठीक है, बेंजीन इज वन एग्जांपल, बट बेंजीन इज नेवर यूज्ड इन क्रोमेटोग्राफी। उसका कारण
ओके
क्या
सर।
है कि बेंजीन इज नाउअडेज ए बैंड सॉल्वेंट।
ओके
ओके,
सर।
तो तुम भी अभी कभी अगर
ओके सर।
लैब में अगर बेंजीन यूज करने की कोई बात करे तो उसको अवॉइड
ओके सर।
करना है। क्यों
ओके सर।
अवॉइड करना है बताओ? बिकॉज बेंजीन जो है, वो बेंजीन जो है ना, बेंजीन बेसिकली जो है वो ऐसे कार्सिनोजेनिक सॉल्वेंट है। ओके,
ओके सर। यस सर।
इसलिए
ओके सर।
बेंजीन को मोस्टली जो है वो बैन कर दिया गया
अवॉइड करते
अनलेस एंड
हैं।
अनटिल कोई
ओके सर।
स्पेसिफिक रिक्वायरमेंट हो।
ओके सर।
ठीक है।
यस सर।
चलो, तो हम लोग यूज करेंगे सॉल्वेंट जैसे मतलब पेट्रोलियम ईथर, हेक्सेन, ये नॉन पोलर
ओके
सॉल्वेंट है,
ओके
तो
सर।
इनसे हम लोग शुरू करते हैं।
ओके सर।
अब इसकी पोलैरिटी कैसे बढ़ाओगे आप? तो ये नॉन पोलर सॉल्वेंट नॉर्मल फेज क्रोमेटोग्राफी के लिए एक वीक मोबाइल फेज बनाएंगे। तो हम शुरुआत वीक
यस
मोबाइल
सर।
फेज से करेंगे। अब उसकी मोबाइल फेज की स्ट्रेंथ कैसे बढ़ाओगे आप?
सर हम उसमें कोई पोलर सॉल्वेंट ऐड करेंगे, वाटर ऐड कर सकते हैं।
हाँ, वाटर ऐड कर सकते हैं, लेकिन वाटर तो ऐड कर नहीं पाएंगे। उसका कारण क्या है कि अगर मैं पेट्रोलियम ईथर में वाटर ऐड करूंगा तो उनकी पोलैरिटी में इतना डिफरेंस है कि वो दोनों घुलते नहीं है। और अगर वो घुलेंगे
ओके मैं
नहीं,
समझ गया,
एक
ठीक है
एक
सर।
एक वाटर फेज
तो
बन
फिर काम
जाएगी,
नहीं होगा।
हाँ एक वाटर फेज बन जाएगी, एक पेट्रोलियम ईथर फेज बन जाएगी, एक स्टेशनरी फेज बन जाएगी। तो
यस सर।
कैसा सिस्टम हो जाएगा? ट्राई फेजिक सिस्टम हो जाएगा।
यस सर।
और क्रोमेटोग्राफी के लिए क्या होना चाहिए हमेशा?
बायोफिजिक्स सिस्टम।
बाईफेजिक होना चाहिए। इसलिए हमको ऐसे सॉल्वेंट्स को मिक्स करना पड़ेगा जो आपस में मिक्सिबल हो।
ओके सर।
तो क्या ऐड करेंगे? जैसे उसके अंदर हम हेक्सेन के अंदर हम लोग क्लोरोफॉर्म ऐड करते हैं, राइट?
ओके सर।
इथाइल एसीटेट ऐड कर
यस
देंगे,
सर।
तो जिससे क्या होगा कि धीरे धीरे उनकी पोलैरिटी बढ़ेगी और मोबाइल फेज की स्ट्रेंथ बढ़ती चली जाएगी। तो याद रखना, एक नॉर्मल फेज क्रोमेटोग्राफी के लिए हम शुरू करते हैं मोबाइल फेज नॉन पोलर से और जाते हैं किसकी तरफ? पोलर
ओके
की
सर।
तरफ। तो धीरे धीरे हम उसकी
पोलर की
पोलैरिटी को
तरफ
क्या करते हैं? बढ़ाते चले जाते हैं। ठीक है, तो आई होप ये सारी
बढ़ाते
चीजें
हैं।
आपको समझ में आ गई हैं। अच्छा, मोबाइल फेज के
यस
बेस
सर।
पे क्रोमेटोग्राफी के क्या क्लासिफिकेशंस हैं?
हेलो। यस सर।
मोबाइल फेज के बेस पे क्रोमेटोग्राफी के क्या क्लासिफिकेशंस हैं?
सर मोबाइल फेस के बेस पे
हम्म
सर इट में बी इधर लिक्विड और गैस।
हाँ, लिक्विड, गैस और सुपर क्रिटिकल फ्लूइड क्रोमेटोग्राफी।
यस सर।
हाँ
सर
तो
कैन
आई
यू
थिंक,
एक्सप्लेन द सुपर क्रिटिकल फ्लूइड? आई डिडंट गेट
हाँ हाँ,
दैट।
यस यस, सुपर क्रिटिकल फ्लूइड क्रोमेटोग्राफी या सुपर क्रिटिकल फ्लूइड एक्सट्रैक्शन एक टेक्निक है जो बड़ी वाइडली यूज्ड है।
ओके सर।
उसमें क्या किया गया एक्चुअली, जैसे अगर आप देखो तो मोबाइल फेज जैसे हमने डिस्कस किया था कि विच वन इज आइडियल मोबाइल फेज, गैस और लिक्विड?
सर गैस।
गैस, वाई?
सर क्योंकि वो इजीली डिस्पर्स हो जाती है।
बिकॉज इट हैज ए इनहेरेंट कैपेबिलिटी ऑफ फ्लो।
यस सर।
हाँ, मोबाइल ही है ना, जबकि
यस
लिक्विड
सर।
कैन बी मेड मोबाइल। ओके,
यस
बट
सर।
लिक्विड कैन
ओके सर।
नॉट बी मेड मोबाइल। अगर आप लिक्विड को एक कंटेनर में भर दो तो वो स्टैग्नेंट हो गया, और
यस
अगर एक
सर।
ग्रेडियंट पे चला दो तो वो मोबाइल हो गया, नहीं?
यस सर। यस सर।
तो वो लिक्विड एक कन्वीनियंट मोबाइल फेज तो है, बिकॉज इजीली आप चला सकते हो उसको। हाँ,
यस
मतलब
सर।
सिस्टम बनाना बड़ा आसान है। एक ट्यूब ली, हायर ग्रेडियंट पे
यस सर।
रखा, लोअर ग्रेडियंट की तरफ चला दिया, बड़ा आसान हो गया। लेकिन
यस सर।
गैस को अगर आपको चलाना है तो क्या करना पड़ेगा आपको? गैस को आपको पहले हाई प्रेशर पे स्टोर करना पड़ेगा और फिर उसको एक कॉलम के थ्रू पास करना पड़ेगा, तब वो एक नॉन लो प्रेशर की तरफ जाएगी। जैसे घर में
ओके
गैस का सिलेंडर होता है ना,
ओके
और
सर।
पाइप के जरिए गैस जो है ना बर्नर तक ही आती है,
यस सर।
नहीं? तो क्योंकि क्यों आती है? उल्टी क्यों नहीं जाती गैस?
यस सर। यस सर।
क्यों नहीं जाती बताओ? उल्टी क्यों नहीं जाती गैस? बर्नर से सिलेंडर में क्यों नहीं चली जाती?
सर प्रेशर डिफरेंस की वजह से।
प्रेशर डिफरेंस, वेरी गुड। तो दैट मीन्स हमको गैस को मोबाइल फेज बनाने के लिए एक सिस्टम बनाना पड़ता है, इक्विपमेंट चाहिए आपको। लेकिन मोबाइल के लिए
ओके
आपको,
सर।
मोबाइल लिक्विड के लिए आपको बहुत ज़्यादा इक्विपमेंट की ज़रूरत नहीं होती, राइट? इसलिए
Yes, sir.
इसलिए ये किया गया। अब अगर मेरे पास चॉइस हो तो मैं हमेशा गैस ही एज ए मोबाइल फेज बनाना चाहूंगा, राइट। लेकिन
Okay,
गैस
sir.
की
Yes, sir.
मोबाइल फेज के साथ प्रॉब्लम क्या होती है कि गैस क्रोमेटोग्राफी से हम केवल उन कंपोनेंट्स को एनालाइज कर सकते हैं जो क्या हो, जो वेपर स्टेट में एग्जिस्ट कर सकते हो।
Yes, sir.
और ये
Yes,
एक
sir.
बड़ी समस्या है बायोलॉजी के लिए, क्योंकि बायोलॉजी में ज्यादातर कंपाउंड वेपर स्टेट में एग्जिस्ट नहीं करते हैं।
नहीं करते हैं। Yes, sir.
हाँ, बिकॉज वी डू नॉट हैव लाइक, अगर आपका प्रोटीन है, डीएनए है, कार्बोहाइड्रेट है, ये कभी वेपराइज स्टेट में नहीं एग्जिस्ट करते। ये हमेशा या तो सॉलिड होंगे या डिजोल्व होकर लिक्विड बन जाएंगे, लेकिन कभी भी
Yes, sir.
वेपराइज नहीं होंगे,
वेपर नहीं होता। Yes, sir.
राइट। तो एक ये सोचा
Yes, sir.
गया कि अगर हम दोनों के कैरेक्टर को मिला दें, मतलब ऐसी मोबाइल फेज जिसकी मोबिलिटी तो गैस जैसी हो और सॉल्वेटिंग पावर लिक्विड जैसी हो, मतलब वो किसी चीज को सोल्यूबलाइज भी कर सके
Okay.
लेकिन
Yes, sir.
गैस के तरीके से मूव कर सके। तो ऐसी
Okay,
ऐसी
sir.
फेज एग्जिस्ट नहीं करती थी, लेकिन इसको बनाया गया। अब आप थोड़ा दिमाग दौड़ाओ, क्या बनाया गया होगा? हाँ, जस्ट यूज योर ब्रेन एंड टेल मी व्हाट दे माइट हैव प्रिपेयर्ड। So what people did actually, people liquefied gases.
Okay, sir.
So if I liquefy a gas like say carbon dioxide, then what will happen? It will be having mobility like a gas.
It will form the liquid.
And it will be a liquefied gas. We cannot call it
Yes,
liquid.
sir.
We will call it liquefied, and that's why we do not call it
Okay.
solvent.
Liquefied gas. Okay.
That's why we do not call it solvent. We call it fluid. We call it fluid.
Okay, sir. Fluid.
Don't call it solvent, because at its
Solvent.
like normal temperature and pressure at NTP, it doesn't exist as a solvent. It exists as a gas. So when we pressurize it at
Okay, sir.
its critical pressure or at its critical temperature, either we reduce the temperature or we increase the pressure. So we will reach at a temperature, like if you keep on cooling a gas, you will reach on a temperature where the gas will be converted in a liquid, in a fluid. that temperature is called TC, critical temperature. Okay. Or if you pressurize a gas,
sir.
then you will reach on a point where the gas will be converted in a liquid again. You might have used the word LPG. You might have heard LPG. What is LPG?
Yes, sir.
What is LPG?
Hello. Yes, sir.
Yes. What is LPG?
Sir, LPG is the compressed gas. Yes, sir. Liquid petroleum gases.
Is it liquid petroleum gas? It is not liquid petroleum gas. It is called
Sir.
It is liquefied petroleum gas.
Oh, okay, sir.
There is a difference between liquid and liquefied.
Okay, sir. Liquefied, yes, sir.
So when you go to home today and you
Yes,
go to
sir.
your kitchen and just shake your cylinder, gas cylinder, cooking
Okay,
gas
sir.
cylinder,
Okay,
you
sir.
will find that you will feel that some liquid is inside, isn't it?
Okay, sir.
But when you open the burner, you never get liquid.
Yes,
You
sir.
only
It's the
get
gas. Yes, sir.
because it is, what is that? What is the cooking gas we are using in the houses?
Cooking gas we're using in the house.
What is LPG actually? LPG is a trade name, but chemically what it is? Chemically what it is?
Sir, it might be some hydrocarbons.
हाँ, हाइड्रोकार्बन्स तो हैं ही। हाइड्रोकार्बन तो पेट्रोल भी है, हाइड्रोकार्बन तो डीजल भी है, पेट्रोलियम प्रोडक्ट है तो हाइड्रोकार्बन तो होगा ही। बट व्हाट इट इज?
Sir, I've heard it before. It might be propane or butane. It might be somewhere around that. I don't know it. I'm not confirmed.
So you have, it is actually butane, right?
Okay, sir.
It is N-butane.
Butane. Okay.
It is N-butane.
Yes, sir.
So at normal temperature and pressure, it is a gas. but it is
Okay, sir.
converted in a liquid by under pressure in a cylinder. And that's why we call it liquefied. We call it liquefied. And
Liquefied. Okay,
since
sir.
it is like it is produced during extraction of petroleum products, so it is called petroleum gas. Okay.
Okay, sir.
Okay, good. So what we do actually in supercritical fluid extraction, we take a gas, we liquefy it, convert it in a fluid, and then do extraction as well as we do chromatography, right? So advantage is
Okay,
that
sir.
like, because suppose I want to extract something of food grade. I think in market there is one product you might have heard about, that is called decaffeinated coffee. Have you heard of it?
Yes, sir. Yes, sir.
What is that? You know what happens actually? Why we drink coffee?
Sir, it's sort of a stimulant.
Stimulant, very good. And stimulant, like what stimulant? Some more idea. Actually, it is a stimulant because of its aroma, right? Coffee
Yes, sir.
got a
Yes,
particular
sir.
aroma. Na? You can just, if you have a cup of coffee or tea in front of you, just by smell, you can tell which one is coffee and which one is tea, right?
Yes, sir.
There are so
Yes,
many
sir.
aromatic compounds in coffee which we like, which is a stimulant, right? But
Right, sir.
apart from stimulant compound, there is an alkaloid in coffee that is called caffeine.
Yes, sir.
So caffeine is actually, it is a habit forming, it's alkaloid. So it's a habit forming molecule.
Okay,
So
okay,
if
sir.
you take coffee for say 5 years, then maybe you will never be able to get rid of coffee throughout your life. Every time you will feel that I need a coffee.
Yes, sir.
It's alkaloid which is having habit forming
Yes, sir.
activity. Now some people says, and then people get addicted to coffee. So initially people start with 1 cup of coffee and then they sip at least 4 or 5 cups of coffee the whole day. And if you consume
Yes,
too
sir.
much of coffee, then it is not good for health, right? So people do not get good sleep and all that. So that kind of
Yes, sir.
problem is there.
Yes, sir.
So in market, we got a coffee in which caffeine concentration of caffeine is less. So how they made it? So initially, the
Okay, sir.
one idea was that people could have done it using organic solvent. Now, caffeine is a intermediate polarity alkaloid, which is highly soluble in, say, intermediate polarity organic solvent like chloroform or ethyl acetate. Now, when we
Okay, sir.
started with this
Okay, sir.
concept, we extracted the coffee beans with chloroform or with a solvent called DCM, dichloromethane. Now problem is like,
Okay, sir.
would you like to have the contamination of chloroform in your coffee?
No, sir.
No, because it is a toxic solvent. So
Yes, sir.
similarly, dichloromethane is also toxic solvent. So we even do not want to have traces of this solvent in our food product. So people thought of that, can we have a similar solvent of similar polarity, which can extract coffee, but it should be like, there should not be any kind of health hazard. So people invented a fluid in form of carbon dioxide. So they use compressed carbon dioxide for extraction of caffeine from the coffee, right? So what they simply did, they took a container in which they took coffee seeds and they pressurized carbon dioxide in that. Now, once the carbon
Okay, sir.
dioxide is pressurized, carbon dioxide will be converted in a, it will be converted in a liquid. And when the coffee beans are in a liquid,
Liquefied CO2.
it will liquefy CO2. So liquefy CO2 will extract
Yes, sir.
caffeine from the coffee beans. And then simply using a wire gauze,
Okay.
you move the coffee bean up and leave the solvent at the bottom, right? And then
Okay,
simply
sir.
simply open the
Yes, sir.
container, simply open the container of the lid of the container. Then what will happen? When you will open the lid, carbon dioxide will come at atmospheric pressure. and at atmospheric
Atmospheric
pressure,
pressure. Yes, sir.
carbon
It will be a
dioxide
gas.
is a gas. So what will happen?
Gas.
The gas
Yes,
will
sir.
evaporate.
Mhm.
At the bottom, you will have caffeine powder.
Caffeine. Okay. Yes,
On
sir.
the wires, you will have your coffee seeds.
Coffee seeds. Yes, sir.
But your coffee seeds now will have
Less caffeine. They are
less
decaffeinated
caffeine.
now.
So you take these
Yes,
coffee
sir.
seeds, grind it, and then use it as a decaffeinated coffee, right?
Yes, sir. Yes,
Got
sir.
it?
Yes, sir.
So that kind of concept is there. Okay.
Okay,
So
sir.
using the same concept, we prepared the supercritical fluid chromatography. Now, advantage of supercritical fluid chromatography is that you can use it for the separation of food grade components, number one, and number two, like there is no need for evaporation of the solvent at a later stage, right? Like if you see this
Mm.
picture, if you want to recover this red color compound, how you will recover this red color compound? Because it is in a solvent, so you have to evaporate solvent. So to evaporate solvent, what you have to do?
Yes, sir.
What you have to do? How you can evaporate a solvent?
So by increasing the temperature.
By increasing the temperature, you have to heat it. Okay.
Yes, sir.
But if your components are food grade, which are likely to be destroyed by high heat, then what will happen? You cannot heat it and you cannot
Yes,
get
sir.
rid of the solvent. So, but if you are
Yes,
using
sir.
liquid carbon dioxide, then what will happen?
Yes, sir. Yes, sir. It will automatically get converted into gas after
Automatically
coming
get
in
converted
contact
to
with
gas.
us.
And if some
Yes,
traces
sir.
of carbon dioxides are still left, it
Yes,
will
sir.
not make you any harm. Right?
Yes, sir. They are harmless.
Okay.
Yes,
So
sir.
this is a very unique chromatography nowadays we are using, largely used in food industry. Okay.
Okay, sir. Yes, sir.
So I hope you have gone through the whole presentation. And now I was expecting you to question me.
Yes, sir. I
Right?
have some questions. Can I ask?
Yes. Tell me.
Okay, sir. So 1 second, please. Sir, uh, there's a slide on slide 46. The separation performance resolution. Okay, so I get that the chromatographic resolution. I understand that. And in the next slide, it is again defined, and that I was not able to get.
Which one? Like which slide you're talking about?
So slide number 47.
Okay, slide number 47. I am here. Like this, you have seen. I think you understood this thing, eh? HPLC and everything.
Yes, sir. Yes,
okay.
sir.
This part you are here, eh?
Yes, sir.
Chromatogram. What is a chromatogram?
So chromatogram, the peak, the map that shows the peak, the concentration.
Okay, so you write down the definition. A developed chromatographic plate is called a chromatogram.
Okay, developed.
Chromatographic plate is called chromatogram.
Yes, sir.
Right. Now, I think you are talking. Yes. You are talking about this slide, eh? Okay.
Yes, sir. Chromatographic resolution.
So resolution is the degree to which two components are separated is called chromatographic resolution. Right? Like here you see there are two compounds, eh? 1 and 2, and this is W1 and W2 is width, peak width. So this is a peak, and this is peak width at bottom, eh? Peak width at bottom. Yes, sir. You can see. So if the two peaks are separated by baseline, then we have a good resolution. You can see a peak came up, came down, and then it touched the baseline. Sir. This is the baseline. It is touching the baseline. So it's a good resolution. Now, if the peak is not touching the baseline like here, like the peak is coming here, then a notch, and then again coming up, means when this compound was eluting, simultaneously the second compound started eluting. So here we say that When the resolution is greater than equal to 1, we have a good separation. And when the resolution is less than 1, the separation is poor. Okay. So
Okay. Okay, sir.
these two peaks indicate that the separation is poor. You can see there are two compounds, but they are not separated
Yes, sir.
properly. So for
Okay, sir.
separation of these compounds, we have to change our stationary mobile phase or maybe stationary phase also. But generally, like stationary phases are fixed, because if you are using a reverse phase column, then generally we use a C18 or a ODS column. So every time we cannot buy a column which is costing us say 30, 40 or 50,000 rupees, right?
Yes, sir.
But yes, I can easily change my mobile phase. So generally an expert chromatographer try to change the what?
Mobile
Try
phase.
to change the mobile phase. Okay.
Mobile phase.
Okay.
Okay, sir. Okay, sir.
So resolution
Yes, sir.
is
This one also.
like, yes, no, like T2 minus T1. That is, T2 is like your T1 is the time of elution of this, RT of this. RT, there is a
Okay,
word
sir.
called
The first
RT.
one.
RT is RT1, this is RT2. So it is T2 minus T1 divided by 0.5 into W1 plus WT, width of first and
First one and the bit of the second.
width of
Okay, sir.
second, right? So like this. So RT is this one, TR1, and this is TR2, time.
Two.
This is
Okay,
TR
okay,
is
for the
time
second one.
retention. Time retention. So this way we can calculate and we can find out that how the resolution is enhanced. So resolution can be
Yes,
improved
sir.
by increasing length of the column, decreasing the particle
Particle
size,
size.
or changing the eluent or the stationary phase. Either we can
Stationary
change the
phase.
solvent or we can change the stationary phase. Like you see
Stationary
here,
phase.
it was a 50 mm column. So you can
Yes,
see
sir.
that the separation was not very good. Now, if I double the length of the column, then the separation is
And the
improved
separation was good.
dramatically.
Yes, sir.
Okay. So
Yes,
all these
sir.
things decide how the separation can be done. Now, this part I was discussing with you, elution series, elution strength. Based on
Yes,
that,
sir.
we got
Yes,
this.
sir.
Like for a normal phase chromatography, where stationary phase is polar in nature, the mobile
Yes,
phase
sir.
will start from cyclohexane, which is the
Okay.
most
Yes, sir.
non-polar, then hexane, toluene, chloroform, methanol, and then finally we
Yes, sir.
reach up to
Water. Okay, sir.
water. Okay. So I
Yes, sir.
hope you
Yes, sir.
understood the whole concept.
Yes, sir.
Now you read it a bit more, and tomorrow, whatever you want to ask, you can ask me in this chromatography. Okay.
Okay, sir.
Then
Okay,
I
sir.
think now we are left with I think 4 or 5 more classes. Just a second, because I think I am just left with how many minutes of free? 2 minutes 19 seconds, are because I generally use it on Zoom, because sharing and everything is easy on Zoom.
Okay, sir.
Okay, so now my class is right. So today is 10th. So I think tomorrow we will like to finish it. Then I would like to discuss with chromatography on 12th, huh?
Okay,
On
sir.
electrophoresis. So tomorrow, if you have
Okay, sir.
any questions related to chromatography, you can ask. Go through the
Okay,
presentation.
sir. Okay,
Then
sir.
because we have radioisotopes also, na. So electrophoresis,
Okay, sir.
I'll discuss tomorrow. I will share electrophoresis PowerPoint with you.
Okay, sir.
And then in the last class, we will discuss about radioisotopes. Okay.
Okay, okay, sir.
Okay, then. So good, but you have to read, unless and until
Yes,
you
sir. Yes,
read,
sir.
because I don't have to read, na, Samra.
Yes, sir.
You
Yes, sir.
have to read and understand, and then try to get the concept and ask me a lot of questions.
Okay, sir.
Right. And then
Yes,
next
sir.
class onwards, you try to find a place where you have little bit better connection.
Okay, sir.
Right. Because I generally
Okay, sir.
find that the connection is not very good at your end.
Yes, sir.
Okay.
Okay, sir.
Okay then. Okay then. So okay, bye bye, and
Oh,
see you tomorrow at
okay.
10.
Okay, sir. Thank you, sir.
Okay then. Bye.